Ever wonder why buildings stand tall, bridges don't collapse, and airplanes don't fall apart in midair? The answer lies in something called structural testing. Imagine a world where structures defy gravity, withstand the forces of nature, and persist through the trials of time. These aren't just feats of engineering brilliance, but also the results of meticulous structural testing. Structural testing is like the unsung hero behind every structure we take for granted. It ensures the safety and durability of everything from the towering skyscrapers to the bridges that connect cities, and even the planes that crisscross our skies. There are various types of structural testing, each with its unique role in the construction process. Non-destructive testing, load testing, fatigue testing, modal analysis, and vibration testing, they all contribute to the strength and stability of our built environment. So buckle up as we delve deeper into the fascinating world of structural testing. It's more exciting than you might think. First off, let's explore non-destructive testing, or NDT for short. Sounds fancy, right? Well, this is where the magic of engineering meets the finesse of medical science. Picture this. Just as doctors use ultrasound and X-rays to peek into what's going on inside our bodies without slicing us open, engineers use similar techniques to look inside structures and materials. Take ultrasonic testing, for instance. It's like shouting into a canyon and waiting for the echo. Sound waves bounce off flaws inside a material, and the echo tells us exactly where those flaws are. Clever, isn't it? Then there's radiography, the X-ray of the engineering world. It uses radiation to see through materials, highlighting any internal defects. It's like having superpower vision that can see through steel and concrete. So NDT is like a doctor's checkup for buildings, only cooler. It's all about finding what's wrong on the inside without causing a scratch on the outside. Now, let's meet some unsung heroes of structural testing: load testing, fatigue testing, and vibration testing. Load testing is like a gym workout for structures. Just as you test your muscles by lifting weights, engineers test structures by loading them up to their maximum capacity to ensure they can take the weight they're designed for. It's a way to flex those structural muscles and make sure they're up to the task. Next up is fatigue testing. Think of it as a stress test, checking how the structure performs under repeated or varying load. It's like running a marathon, but for buildings and bridges, to make sure they won't buckle under pressure over time. Finally, there's vibration testing. This is like the structure's dance class, where they're exposed to different frequencies and amplitudes to see how they handle the shakes. It's key to ensuring that buildings won't crumble under the effects of earthquakes or heavy traffic. So, next time you're in a shaking elevator, remember to thank the vibration testers for making sure it can handle the shake, rattle, and roll. Lastly, we have the cherry on top, modal analysis. This is the final piece of the structural testing puzzle, and it's every bit as crucial as its counterparts. Modal analysis is a bit like reading the structure's diary. It tells us how a structure responds to different inputs, from the gentlest breeze to the most violent earthquake. Think of it as a conversation between the structure and the forces acting upon it. The structure whispers its secrets to us, revealing its strengths and weaknesses. It helps us identify areas that need improvement and guides us in making those changes. Modal analysis is not just a test. It's a tool for understanding and improving. Its importance in the grand scheme of structural testing cannot be overstated. And there you have it. The world of structural testing is full of intrigue and importance. So the next time you marvel at a towering skyscraper or a soaring airplane, remember the unsung heroes of structural testing that make it all possible?